the condition that the line x by p plus y by q equals to 1 to be a tangent to the hyperbola x square by a square minus y square by b square equals to 1. If suppose the straight line Lx plus my plus n equals to 0, Lx plus my plus n equals to 0 is a tangent to the hyperbola, condition a square L square minus b square m square equals to n square, a square L square minus b square m square equals to n square. Now a square into L square equals to 1 by p whole square minus b square only, m square equals to 1 by q whole square equals to n square nothing but 1, n equals to 1. Now a square by p square minus b square by q square equals to 1. The required condition a square by p square minus b square by q square equals to 1. Second option is the correct. Second option. If the line 3x minus y plus k equals to 0, 3x minus y equals to k or minus k equals to 0 is a tangent to the hyperbola 3x square minus y square equals to 3, then k equals to, now the equation converted into standard form x square by 1 minus y square by 3 equals to 1. Here a square equals to 1, b square equals to 3. The line in the form of Lx plus my plus n equals to 0. Now Lx plus my plus n equals to 0 is a tangent to the hyperbola. Then the condition is a square L square minus b square m square equals to n square. Now a square equals to 1 into here L equals to coefficient of x, L square equals to 9 or 3 square minus b square is 3 into m square minus 1 whole square equals to n square k square. Now 9 minus 3 equals to k square, for implies k equals to plus or minus root 6, k equals to plus or minus root 6. Now fourth option is correct. Fourth option. The point of contact of 9x plus 8y minus 11 equals to 0 to the hyperbola 3x square minus 4y square equals to 11. Now the equation of the hyperbola in the standard form x square by 11 by 3 minus y square by 11 by 4 equals to 1. In the standard form x square by 11 by 3 minus y square by 11 by 4 equals to 1. Now if suppose the line Lx plus my plus n equals to 0, Lx plus my plus n equals to 0 is a tangent to the standard hyperbola x square by a square minus y square by b square equals to 1, then the point of contact minus a square L by n comma b square m by n. The point of contact minus a square L by n comma b square m by n. Now here a square equals to 11 by 3. Now minus 11 by 3 into L 9 by n equals to minus 11 comma b square equals to 11 by 4 into m equals to 8 by minus 11. Now here minus minus cancel, 11 cancel, 3 times cancel. Now x coordinate 3, for 2 times cancel, 11 cancel, minus. Now 3 comma minus 2, 3 comma minus 2 is the required point of contact, then first option is the correct. First option. The locus of point of intersection of two tangents to the hyperbola x square by a square minus y square by b square equals to 1, x square by a square minus y square by b square equals to 1 which makes an angle 90 degrees with one another, means angle between the pair of tangents 90 degrees, required the locus of point of intersection of the tangents. Now, if suppose consider m1 and m2 are slopes of the tangents drawn from px1 by 1, Now, product of slopes equals to y1 square plus b square by x1 square minus a square, but product of slopes equals to minus 1, because the angle between the tangents is 90 degrees, then product of slopes equals to minus 1, that equals to minus 1. By cross multiplication, y1 square plus b square equals to minus x1 square plus a square. Now, x1 square plus y1 square equals to a square minus b square. Then locus of px1 by 1 is x square plus y square equals to a square minus b square. X square plus y square equals to a square minus b square. Second option is the correct. The pole of the line 2x plus 3y minus 6 equals to 0 with respect to the hyperbola x square by 3 minus y square by 2 equals to 1. The pole of the line, if suppose line equation Lx plus my plus n equals to 0 and hyperbola equation x square by a square minus y square by b square equals to 1. Now, the pole of the line Lx plus my plus n equals to 0 with respect to the hyperbola is minus a square L by n, comma b square m by n. Pole equals to minus a square L by n, comma b square m by n. Now, that equals to, here the value of a square equals to 3, minus 3 into L equals to 2 by n minus 6, comma b square equals to 2, m equals to 3 by n equals to minus 6. Now, minus get cancel, 3 into 2 6, 6 also cancel 1. Similarly, 6 by minus 6 minus 1. Now, the pole of the given line with respect to the given hyperbola is 1 comma minus 1, 1 comma minus 1. Third option. If 2 comma 3, 4 comma k, 2 comma 3, 4 comma k are conjugate points with respect to the hyperbola, 3x square minus 4y square equals to 12, 3x square minus 4y square equals to 12, then k equals to, if suppose the given points x1 by 1 and x2 by 2 consider, the 2 points x1 by 1 and x2 by 2 are conjugate with respect to the given hyperbola, then the condition is s12 equals to 0, s12 equals to 0. 2 points are conjugate points with respect to a hyperbola, condition s12 equals to 0. Now, s12 nothing but 3x1 x2 minus 4 into y1 y2 equals to 12. Now, here x1 equals to 2, x2 equals to 4, y1 equals to 3, y2 equals to k. Substituting in this equation, 3 into 2 into 4 minus 4 into 3 into k equals to 12. Now, 24 minus 12k equals to 12. 12 take left side, 24 minus 12, 12 equals to 12k. Then k equals to 1. The value of k equals to 1. K equals to 1. First option is correct. First option. If the lines 4x minus ky minus 6 equals to 0, x minus y minus 1 equals to 0, x minus y minus 1 equals to 0 are conjugate with respect to the hyperbola 2x square minus 3y square equals to 6, 2x square minus 3y square equals to 6, then k equals to, require the value of k, If suppose the two lines, one is L1x plus M1y plus N1 equals to 0, Second line L2x plus M2y plus N2 equals to 0. And the hyperbola equation x square by a square minus y square by b square equals to 1. Now the lines L1x plus M1y plus N1 equals to 0 and L2x plus M2y plus N2 equals to 0 are conjugate lines with respect to the hyperbola x square by a square minus y square by b square equals to 1. Then the condition a square L1 L2 minus b square M1 M2 equals to N1 N2. The two lines are conjugate lines with respect to the hyperbola. Then the condition a square L1 L2 minus b square M1 M2 equals to N1 N2. Now the given hyperbola equation x square by 3 minus y square by 2 equals to 1. Now here a square equals to 3, b square equals to 2. A square equals to 3, b square equals to 2. L1 equals to 4, M1 equals to minus k, N1 equals to minus 6, L2 equals to 1, M2 minus 1, N2 also minus 1. Now substituting a square equals to 3 into L1 L2, 4 into 1 minus b square 2 into M1 M2, M1 equals to minus k, M2 equals to minus 1 equals to N1 N2 minus 6 into minus 1. Now 3 into 4, 12 minus of minus plus 2k equals to 6. Now 2k equals to minus 6 for implies k equals to minus 3. The value of k equals to here minus into minus into minus 2k. Minus 2k equals to minus 6. Now k equals to 3. K equals to 3. First option. The locus of poles with respect to the hyperbola x square by a square minus y square by b square equals to 1, x square by a square minus y square by b square equals to 1 of tangents its auxiliary circle. Tangents its auxiliary circle. Now equation of auxiliary circle of the hyperbola is x square plus y square equals to a square. X square plus y square equals to a square is auxiliary circle of the given hyperbola x square by a square minus y square by b square equals to 1. Now first to consider p x1 y1 with the pole. Now equation of polar of p with respect to the hyperbola x1 by a square minus y1 by b square minus 1 equals to 0 or s1 equals to 0. Equation of the polar s1 equals to 0, that is nothing but x1 by a square minus y1 by b square minus 1 equals to 0. But it is tangent to the auxiliary circle. Auxiliary circle x square plus y square equals a square. Now a straight line and a circle touch each other, then perpendicular distance from center of the circle to the line equals to radius. Now center of the circle 0, 0, radius of the circle a. Now perpendicular distance from 0, 0 to this line minus 1 by square root of x1 by a square whole square plus y1 by b square whole square mod. But that equals to radius of the circle a. Now squaring on both sides and reciprocal it, we get x1 square by a power 4 plus y1 square by b power 4 equals to 1 by a square. Then locus of x1 y1 is x square by a power 4 plus y square by b power 4 equals to 1 by a square. The required locus is x square by a power 4 plus y square by b power 4 equals to 1 by a square. Now first option is the correct. The equation to the pair of asymptotes of the hyperbola 2x square minus y square equals to 1. Now the given hyperbola equation x square by 1 by 2 minus y square by 1 equals to 1. Now it is in the form of x square by a square minus y square by b square equals to 1. Now equation of asymptotes nothing but x square by a square minus y square by b square equals to 0. Equation of asymptotes of the hyperbola x square by a square minus y square by b square equals to 1 is x square by a square minus y square by b square equals to 0, because only the equation of the hyperbola and its asymptotes differ by only constant k. Now, the required equation of asymptotes x square by 1 by 2 minus y square by 1 equals to 0, or 2x square minus y square equals to 0 is the required equation of asymptotes of the given hyperbola. Second option. The angle between the asymptotes of the hyperbola x square by a square minus y square by b square equals to 1. X square by a square minus y square by b square equals to 1 is, it is a formula. If eccentricity of the hyperbola is E, then angle between the asymptotes equals to 2 secant inverse E. 2 secant inverse E. Now, fourth option. The asymptotes of a rectangular hyperbola intersect at an angle. Now, only angle between the asymptotes is 90 degrees, then the hyperbola is called rectangular hyperbola. That is the definition. Then angle between the asymptotes of a rectangular hyperbola is 90 degrees or pi by 2. Fourth option. The combined equation of asymptotes of the hyperbola xy plus x plus y plus 5 equals to 0. xy plus x plus y plus 5 equals to 0. Now, given a equation of the hyperbola, required asymptotes equation. Now, always equation of the hyperbola and its asymptotes equation differ by some constant k. Now, the equation of asymptotes must be in the form of xy plus x plus y plus some another constant k equals to 0. Now, asymptotes nothing but two tangents to the hyperbola. Tangent nothing but a straight line. Two tangents means a pair of straight lines. Now, second degree general equation represents a pair of straight lines. Then condition delta equals to 0, or delta nothing but ABC plus 2FGH minus AF square minus BG square minus CH square equals to 0. Now, by using this condition, we get the value of k. By using this condition, we get the value of k. Now, here a nothing but coefficient of x square. There is no x square term. Then ABC equals to 0 plus 2FGH. 2 into f nothing but half of the coefficient of y, 1 by 2. G equals to half of the coefficient of x, that is also 1 by 2. H equals to half of the coefficient of x5, 1 by 2. Minus AF square 0, minus BG square also 0, minus CH square. C nothing but k, H equals to 1 by 2 whole square equals to 0. Now, 1 2 cancel, 1 by 2 into 1 by 2, 1 by 4 minus k by 4 equals to 0, then k equals to 1. Then required equation of the asymptotes is xy plus x plus y plus 1 equals to 0. Now, by factorization, in first two terms x common, y plus 1 plus y plus 1 equals to 0. Now, x plus 1 into y plus 1 equals to 0 is the required asymptotes equation. Now, fourth option is correct. Fourth option. The equation of the hyperbola whose asymptotes are 2x plus y minus 1 equals to 0, x minus 3y plus 4 equals to 0, and which passes through the point 2 comma minus 1, which passes through the point 2 comma minus 1. Now, given asymptotes, separate equations of asymptotes of the hyperbola, and hyperbola passing through the point 2 comma minus 1, passing through the point 2 comma minus 1. Now, required equation of the hyperbola. Now, combined equation of asymptotes. Given separate equations, just multiplying together, we get combined equation of asymptotes. 2x plus y minus 1 into x minus 3y plus 4 equals to 0. Now, it is combined equation of asymptotes of the given hyperbola. Now always the equation of the hyperbola and its asymptotes differ by some constant. Now consider hyperbola equation, asymptotes equation plus some constant k equals to 0. Asymptotes combined equation plus some constant k equals to 0. But the hyperbola passing through the point 2 comma minus 1. Now substituting that point in the equation, it must be satisfied. Now substitute the point 2 comma minus 1 in the equation of the hyperbola. At place of x equals to 2, substituting 4 y equals to minus 1 into 2 minus of minus plus 3 plus 4 plus k equals to 0. 4 minus 1 minus 1, 2 into 2 plus 3 plus 4, 9 plus k equals to 0. For implies k equals to minus 18. Just k equals to minus 18, substitute and simplify. Now by multiplication we get 2x square, 2xy, 2x into minus 3y, minus 6xy plus xy, minus 5xy, y into minus 3y, minus 3y square, 2x into 4, 8x minus x plus 7x, y into 4, 4y plus 3y plus 7y minus 4 minus 18 minus 22 equals to 0. Now third option is correct. Third option. The equation of the normal to the hyperbola x square by 25 minus y square by 9 equals to 1. X square by 25 minus y square by 9 equals to 1 at the point theta equals to pi by 4. At the point theta equals to pi by 4. Now equation of the normal at the point theta is ax by secant theta plus by by tan theta equals to a square plus b square. Equation of the normal to the standard hyperbola x square by a square minus y square by b square equals to 1 is ax by secant theta plus by by tan theta equals to a square plus b square. Now here a square equals to 25, b square equals to 9 and theta equals to pi by 4. Substituting a equals to 5 x by secant 45 root 2 plus b equals to 3 into y by tan 45 1 equals to a square plus b square 25 plus 9. Now taking LCM as root 2, we get 5x plus 3 root 2y equals to 25 plus 9, 34 root 2. The required equation of the normal at the point theta equals to pi by 4 is 5x plus 3 root 2y equals to 34 root 2. 34 root 2. Now first option is correct. First option. Next, polar coordinates. Polar coordinates. If suppose origin, consider origin, O is the origin. Now positive x-axis, positive x-axis. Now here origin is called pole and the positive x-axis is called polar axis, polar axis, or it is also called initial line or polar axis. Now origin is called pole and the positive x-axis is called initial line or polar axis. If suppose P is any point in the plane, such that the distance between OP, the distance between the pole and the point P is r units and OP inclined an angle theta with polar axis. The distance between O and P is r units and OP inclined an angle theta with polar axis. Then the polar coordinates of the point P r comma theta. the polar coordinates of the point P r comma theta. Now here r is called radius vector of the point P and theta is called vectorial angle of the point P. If suppose r1 theta 1, r2 theta 2 are 2 points, r1 theta 1 and r2 theta 2 are 2 points, then the distance between 2 points, if suppose the points P and Q consider, now PQ equals to, the distance between 2 points equals to square root of r1 square plus r2 square minus 2 r1 r2 cos of theta 1 minus theta 2. The distance between the points P r1 theta 1, Q r2 theta 2 is PQ equals to square root of r1 square plus r2 square minus 2 r1 r2 cos of theta 1 minus theta 2. Cos of theta 1 minus theta 2. Next, if suppose OX is polar axis, P r comma theta is any point. If suppose take x axis and y axis, with respect to the rectangular coordinate axis, the coordinates of the same point P x1 comma y1 and polar coordinates r comma theta. Here OP equals to r and OP inclined an angle theta with the polar axis. If suppose draw a perpendicular from P to x axis or PM perpendicular to polar axis or positive x axis. Now the Cartesian coordinates of the same point P is x1 y1, then OM equals to x1, PM equals to y1. OM equals to x1, PM equals to y1. Now in triangle OPM, cos theta equals to adjacent side by hypotenuse x1 by r, for implies x1 equals to r cos theta. Similarly, sin theta equals to y1 by r, y1 equals to r sin theta. If suppose the Cartesian coordinates x1 comma y1 equals to r cos theta comma r sin theta, in terms of r and theta, x1 y1 values r cos theta comma r sin theta. Now x1 square plus y1 square and add these two equations, we get r square, for implies r equals to square root of x1 square plus y1 square. Now similarly in triangle OPM, tan theta equals to y1 by x1, for implies theta equals to tan inverse y1 by x1. Now r comma theta in terms of x1 and y1 is r equals to square root of x1 square plus y1 square comma tan inverse y1 by x1. Now it is the relation between Cartesian coordinates and polar coordinates. x1 y1 equals to r cos theta comma r sin theta, r comma theta equals to square root of x1 square plus y1 square comma tan inverse y1 by x1. Next problem, the Cartesian coordinates of 4 comma pi by 3. The Cartesian coordinates of 4 comma pi by 3. Now given r comma theta. Now here r equals to 4, theta equals to pi by 3. Required x1 y1 Cartesian coordinates. Now x1 y1, x1 equals to r cos theta, y1 equals to r sin theta, y1 equals to r sin theta. Now x1 y1 r cos theta comma r sin theta, but here the value of r equals to 4 into cos 60 degrees 1 by 2 comma r equals to 4, sin theta equals to sin 60, or that equals to root 3 by 2. Now that equals to 2 comma 2 root 3. Now the required point 4 comma pi by 3 equals to 2 comma 2 root 3. Now Cartesian coordinates of the given point 4 comma pi by 3 is 2 comma 2 root 3. First option. the Cartesian equation of r square sin 2 theta equals to a square. The Cartesian equation of r square sin 2 theta equals to a square. Now, r square into sin 2 theta equals to 2 sin theta cos theta, that equals to a square. Now, here r square can be written as r into r, or 2 into 1 r into cos theta or sin theta, second r into cos theta equals to a square. Now, r cos theta equals to x, r sin theta equals to y. Now, we get 2xy equals to a square. The required Cartesian equation of the curve is 2xy equals to a square, third option. The Cartesian equation of r equals to 5 cos theta plus 12 sin theta. The Cartesian equation of r equals to 5 cos theta plus 12 sin theta. Now, the complete equation multiplied with r square equals to 5r cos theta plus 12r sin theta. Means both sides multiplied by r, we get r square equals to 5r cos theta plus 12r sin theta. But r square value in terms of x and y, x square plus y square equals to 5 into r cos theta equals x plus 12 into r sin theta y. Now, the required equation x square plus y square minus 5x minus 12y equals to 0. X square plus y square minus 5x minus 12y equals to 0. Now, second option is correct. The condition for the lines C1 by r equals to a1 cos theta plus b1 sin theta and C2 by r equals to a2 cos theta plus b2 sin theta, to be perpendicular. First, the given equations convert into Cartesian form. The given polar equations of the lines convert into Cartesian form. Now, by cross multiplication, C1 equals to a1 r cos theta plus b1 r sin theta. Now, C1 equals to a1 into r cos theta equals to x. Now, a1x, similarly b1y. First line equation C1 equals to a1x plus b1y. Similarly, second equation cross multiply, we get C2 equals to a2x plus b2y. But in problem given, these two lines are perpendicular to each other. Then the condition. Now, product of slopes of two lines must be equals to minus 1. Product of slopes. Two lines are perpendicular to each other. Product of slopes equals to minus 1. Now, slope equals to minus coefficient of x by coefficient of y. Now, minus a1 by b1 is slope of the first line. Similarly, slope of the second line minus a2 by b2. The product of slopes equals to minus 1. Here minus into minus place, a1 a2 equals to minus b1 b2, or minus b1 b2 take left side, a1 a2 plus b1 b2 equals to 0 is the required condition. a1 a2 plus b1 b2 equals to 0, first option. The length of the perpendicular from minus 1 comma pi by 6 to the line r into 3 sin theta plus root 3 cos theta equals to 3 is required. The length of the perpendicular from the given point minus 1 comma pi by 6 to the line r into 3 sin theta plus root 3 cos theta equals to 3. Now, the given point minus 1 comma pi by 3 convert in terms of x and y are Cartesian coordinates. Now, here given r comma theta, first x comma y equals to r cos theta comma r sin theta. Here r equals to minus 1. Now minus 1 into cos theta, cos pi by 3, cos pi by 6, cos 30 degrees equals to root 3 by 2, comma minus 1 into sin 30 degrees 1 by 2. Now therefore the point is minus root 3 by 2, comma minus 1 by 2, minus root 3 by 2, comma minus 1 by 2. Similarly, the equation of the straight line also convert into Cartesian form. Now r sin theta equals to y, r cos theta equals to x. Now we get root 3x plus 3y minus 3 equals to 0. The equation, Cartesian equation of the straight line is root 3x plus 3y minus 3 equals to 0. Now required perpendicular distance from minus root 3 by 2 comma minus 1 by 2 to this line equals to, now root 3 into minus root 3 by 2 plus 3 into minus 1 by 2 minus 3 by square root of root 3 whole square plus 3 square. Now the perpendicular distance formula ax1 plus by1 plus c by square root of a square plus b square. Now further simplifying, we get root 3 into root 3, 3 minus 3 by 2 minus 3 by 2 minus 3 whole by square root of 3 plus 9, or that equals to minus 3 by 2 minus 3 by 2 minus 3 minus 3 minus 6 by square root of 12. Now that equals to, always perpendicular distance is positive. Now 6 by root 12, root 12 can be written as 2 root 3. Now 2 3 times cancel, 3 by root 3, that equals to root 3. Now the perpendicular distance or length of the perpendicular from given point to given line equals to root 3, third option. The polar equation of the circle whose center at 2 comma pi by 4, center 2 comma pi by 4 and radius 3 units. If suppose circle, the center of the circle C comma alpha, center consider C comma alpha, any point C comma alpha, here given 2 comma pi by 4, C comma alpha, and radius equals to a units. Radius of the circle consider a, radius equals to consider a, radius of the circle equals to a, consider. Now required equation of the circle, polar equation of the circle. If suppose let O be the pole, OX is polar axis, OX polar axis. Now the coordinates of the center is C comma alpha, then OC equals to C, the distance between O and C equals to C units, and OC inclined an angle alpha, OC inclined an angle alpha with the polar axis, because the coordinates of center C comma alpha, then OC equals to C and OC inclined an angle alpha with the polar axis. Consider PR comma theta be any point anywhere on the circumference of the circle, then the locus of the point PR comma theta is the required circle. Now the polar coordinates of the point PR comma theta, then OP equals to R units and OP inclined an angle theta with the polar axis, OP inclined an angle theta with the polar axis. Now in triangle OCP, OP equals to R, OC equals to C and CP equals to A, and OP inclined an angle theta with polar axis, OC inclined an angle alpha with the polar axis. Then in triangle OPC, angle O equals to theta minus alpha. Now in triangle OPC, from cosine rule, cos of theta minus alpha. Cos of theta minus alpha equals to a square from cosine rule. Cos of theta minus alpha equals to r square plus c square, r square plus c square minus a square equals to 2rc cos theta minus alpha. From cosine rule, a square equals to r square plus c square minus 2rc cos theta minus alpha. From cosine rule, in triangle OPC, a square equals to square of the opposite angle to theta minus alpha equals to sum of squares of adjacent sides minus 2 into product of the two sides into cos of that angle. Now r square minus 2rc cos theta minus alpha, r square minus 2rc cos theta minus alpha equals to a square minus c square, a square minus c square. Now this is the required equation of the circle whose center c comma alpha and radius a, center c comma alpha, radius a. Now radius a equals to 3, c comma alpha equals to 2 comma pi by 4. Here the value of c equals to 2, alpha equals to pi by 4, a equals to 3. Substitute in the equation, we get r square minus 2cr. Here c equals to 2. Now 2 into 2, 4 r cos theta minus pi by 4 equals to a square minus c square. A equals to 3, a square equals to 9. Now c square equals to 4, 9 minus 4, 5. Now the required equation of this circle is r square minus 4r cos theta minus pi by 4 equals to 5. Now third option.